Hello, Kim 121, and welcome back to Chemistry with Professor Tabitha Ship. So, I am going to go over a video with you that deals with double and triple bonds. So, in the last couple of videos you may have seen or may have watched, there were some videos where I just dealt with single bonds. So, in this video, I'm going to deal with double and triple bonds. So, on the screen now, I have the oxygen atom, just oxygen, attached to itself. Watch what happens when I go ahead and work the problem out and show you what you'll have, okay? So I know I have 3 oxygen atoms and they are part of group 16, so they're going to each contribute 6 valence electrons for a total of 18. I should have 18 dots all around my structure, okay? 18 dots, all right? Dots, valence electrons, tomato, tomato, just to give you the point, you need 18 of them. Now, it doesn't matter which oxygen you place where because they're all the same. So I'm just going to go ahead and take the first oxygen, just place it in the middle and watch this. I have 2, 4, and 6, okay? Now, what I'm going to do is change my pen so that you can see a different oxygen come on the scene. So here we go. This is 2, 4, and 6. Now, notice I didn't start here because there was already one bond established there. So I didn't need to start my count here, okay? So I actually started at the very top and worked around it. Now, here comes my third oxygen, okay? So let me go ahead and change the color so you guys can see the new oxygen coming on the scene. Here we go. 2, 4, and 6. Now, question. How many pairs of valence electrons do you see around the red oxygen? Right here. I see 8, and you should too. Let's look at the green oxygen. How many do you see over here around the green oxygen? I see 2, 4, 6, 8 also. You should as well. Now, here's the one that's complaining. The one in the middle. And let me tell you why. Or maybe you can tell me why. How many do you see around this one? If you said 6, you are correct. There are only 6 valence electrons, and that is a problem. Why is it a problem? Because they need 8. That is the lucky number in chemistry, okay? 8, 8, 8. If the red oxygen has 8 and the green oxygen has 8, the purple oxygen also must have 8. So this is what we're going to have to do. We're going to have to remove from either the green or the red. Let's go ahead and take them from the green, all right? So let me go ahead and erase the mess so we can go ahead and put the 8 that we need around it, okay? So what I'm going to do next is take these 2 here and just move them right there, okay? So I'm going to go ahead and delete those off right there. You see that? I'm erasing those, okay? So that you can have the 8 that you need. Now, with the swap of my pen, I'm just going to go ahead and erase. Now, if you take a look at what you have here, okay, you now have 2, 4, 6, 8 around the green oxygen, still have 8 around green, but now you have 2, 4, 6, 8 around the purple, and the red, you still have 8, 2, 4, 6, 8. So this completes your pick in terms of completing your valence electrons. Now you can go back and add those dots up, 2, 4, 6, 8, 10, 12, 14, 16, and 18, and you should get the total number that you see right there, okay? So now what I'm going to do is redraw this picture because you know what we have to do, right? We've got to show how we replace those pairs of electrons with the bonds. Meaning, right there in the middle, these 2 right here will be replaced with a double bond. And right here, you've got the valence electrons, and your picture is complete. So you have one single bond and a double bond. And then if I ask you how many non-bonding pairs of electrons, that means they're not attached to anything. I'm going to highlight them in yellow so you can see. You've got 1, 2, 3, 4, 5, 6, and 7 non-bonding pairs of electrons, okay? Let's do another double or triple bond example. All right, so suppose I have hydrogen. Oh, let me change my marker. Suppose I have hydrogen, I'm sorry, sodium cyanide. Yeah, it's something about that sodium that I like. Sodium cyanide. Okay, well, separate everything out. I've got 1 sodium, 1 carbon, 1 nitrogen. Now I'm going to go in and multiply them each by their appropriate number of valence electrons. I know that sodium is in group 1, so it has 1 valence electron times 1. I have 1 carbon, but it's in group 14, so it has 4 valence electrons. And then I have 1 nitrogen, but it's in group 15, so they are contributing 5 valence electrons. So I'm going to add all these numbers up, and I get 10. So now I'm going to go over here and start with my first drawing. I've got sodium coming in with 1 valence electron. I'm going to go ahead and add my carbon. Carbon has 4, but here we go. 1, 2, 3, and 4. And then my last element, which is nitrogen. And let me change the marker so you guys can see a new element coming on. Okay, here we go. Here's nitrogen with 5. Start there to make that bond. So that's 1, 2, 3, 4, 5. Now let's go back and count how many each element needs. Remember, carbon and any element that is part of groups 15, 16, and 17 must have 8. 8 is the lucky number in chemistry. So if I look at my carbon, I have 2, 4, 6 around carbon. Nitrogen has 2, 4, 6 around it. So let me give you the little silly example that I gave earlier about who's contributing what in order to make this whole process work. Now remember, carbon and nitrogen both need 8. But in order to make that happen, they're going to have to share. So nitrogen is like, oh, okay. Well, in order to make you happy, carbon, because you are the middle element, I'm going to take 2 from me and move them right here. So I'm going to take these 2 on the top and move them right here. So this is your 2 valence electrons that I just moved. Okay? Now I'm going to erase those so you don't see them anymore. Now, carbon's like, okay, well, I'm happy, but not really. Why am I not happy? Tell me, why am I not happy? I think one of those nitrogens got erased. There we go. Why are we not happy? Well, carbon says, well, I have my 8. See, that's 2, 4, 6, 8. But nitrogen's like, well, I'm not happy because I just gave you 2 of mine, but I need 2 of yours now. So I need 2 more because I only have 6. See, that's 2, 4, 6. So you're going to take these 2 from the top up here and move them right there in the middle. So they both can have 8. So when you do that, you end up with 2, 4, 6, 8 around carbon and 2, 4, 6, 8 around nitrogen. But we've got to redraw this picture so we can see the final pick and the final assessment. You're going to end up with sodium a dash here to show that bond, carbon, and 2, 4, 6. Okay. And if you look at the total here around carbon, you've got 2, 4, 6, 8. And then nitrogen, pull that one on in, plus the extra 2 right there on the side to give this a total of 8. So sodium cyanide has one single bond and a triple bond. Now, let me tell you the unique thing about this whole picture. If I told you all to draw the structure for, let's say, hydrogen cyanide, okay, guess what? It's going to look the same way. You know why? Because sodium and hydrogen are in the same group. And if they're in the same group, any combinations that you do will have the same pick. All I'm going to do is just replace that first element with hydrogen. And so your picture will look just like this. If I told you to draw the structure for potassium, cyanide, guess what? It's going to look the same exact way because potassium is also a part of that same group. Potassium, sodium, lithium, any element that's in group 1 combined with cyanide will look the same exact way. Let me give you another example. One more. Let's say that I gave you sulfur dioxide, okay? Sulfur dioxide. So, of course, you do your math. You're going to multiply each of them by their respective numbers of valence electrons, okay? This is 6 right here, and I have 6 valence electrons to give me a total of 12 for oxygen. I have a total of 18. Now, if I go back and I remember my picture from before, where I did oxygen up here, look, oxygen, O3, is in the same group, excuse me, as sulfur and oxygen. In other words, sulfur dioxide, SO2, is going to look the same as O3. Why? Because sulfur and oxygen are in the same group. And if they're in the same group, the picture is going to look identical. You just have different elements. So watch this. To show you what I mean, I'm going to put sulfur right there in the middle with 6, 2, 4, and 6. And now here comes oxygen. 2, 4, and 6. Here comes the other oxygen. 2, 4, and 6. Now, if you notice, the oxygens have 8, but sulfur in the middle only has 6. So you can take from either the left side or the right side. It doesn't matter. Let's take from the right side. I'm going to take those 2 and put them right there. Let me erase the 2 that you see at the very top over here. And now your picture shows you that you have 8 around sulfur. See that? So let me highlight it so you can see it. Right here. I've got 2, 4, 6, 8. And each of my oxygens also have 8. See this? 2, 4, 6, 8. And over here, I've also got 2, 4, 6, 8 as well. Now, you know we can't leave our picture like this, so let's go ahead and redraw this picture showing the correct structure of the molecular bonds. So here we go. I'm going to have sulfur plus my oxygens. Okay, so our picture is complete. Picture is complete. Okay? All right. The next video that we load up is going to be on how do you determine the shapes? How do you determine the shapes? So stay tuned.